baru buka. Dekat-dekat sini je weh.
Weh, seronoknya. Aku rasa aku nak cakap kat kakak aku lah, nak suruh ajak family aku pergi sekali.
Oh, okey juga. Aku pun macam nak ajak family aku lah.
Sabar je lah.
Kak, kau tahu tak ada taman tema air baru buka? Ya ke? Macam menarik je. Jomlah kita ajak family kita pergi. Ya kan? Sis kita pun dah lama tak keluar sama-sama. Tapi macam mana kita nak tahu bajet kita berapa? Oh.
First, let's go through the history of determinants. The concept of determinants originated in the 17th century through the work of mathematicians studying system of linear equations. The first known appearance of determinant-like ideas was by the Japanese mathematician Seki Takakazu around 1683 and independently by the German mathematician Gottfried Wilhelm Leibniz in 1693. In the 18th century, the French mathematician Gabriel Cramer introduced Cramer's rule, which used determinants to solve system of linear equations. Later, Simon Laplace developed the cofactor expansion method, making determinant calculation more systematic. During the 19th century, determinants became an important part of linear algebra through contribution from mathematicians such as Augustin Louis Cauchy and Arthur Kelly. Their work established determinant as a fundamental tool for studying matrix, vector space, and linear transformation. Today, determinants are widely used in mathematics, engineering, physics, computer graphics, and data science.
Next, I will proceed with problem statement. Many families plan to visit Extreme World Park during weekends, school holidays, and special occasions. However, different categories of visitors are charged different ticket prices, such as adult, child, senior citizens, and foreigner tickets. When only package transaction information is available, families may find it difficult to determine the exact ticket prices and estimate the total cost of their visits. Therefore, a mathematical method is required to determine the ticket prices accurately and assist families in planning their budget. In this project, the Algebra method is used to solve a system of linear equations and calculate the prices of the different ticket categories. For the objective, it is to determine the prices of adult, child, senior citizen, and foreigner tickets at Extreme World Park using the Algebra method. And secondly, it is to estimate the total ticket budget required for a family visiting Extreme World Park.
First, we define the variables based on the ticket categories, where W represents adult tickets, X represents child tickets, Y represents senior citizen tickets, and Z represents foreigner tickets. Next, all the information given in the question is written as a system of linear equations. After that, the equations are converted into matrix form Ax equals to B, where A is the coefficient matrix, X contains the unknown variables, and B is the constant matrix. This matrix form allows us to apply the adjoint method. Before applying the adjoint method, we first ensure that matrix A is a square matrix because the method can only be used for a square matrix. Then we calculate the determinant of matrix A. If the determinant is not equal to 0, the matrix is invertible, and we can continue with the solutions. Next, we calculate the cofactor of each element in matrix A using the cofactor formula to obtain the cofactor matrix. After obtaining the cofactor matrix, we transpose it to form the adjoint matrix. Next, the inverse of matrix A is calculated using the formula A inverse equals 1 over the determinant of A multiplied by the adjoint of A. Finally, we multiply A inverse by matrix B to obtain matrix X. The values of W, X, Y, and Z in matrix X represents the final solutions for each ticket category.
Now, we move to the application of adjoint method. First, we let the variable for each category ticket W, X, Y, and Z. Next step, we form the system of linear equations based on the information given. The equation is W plus X plus Y plus Z equal to 564. Second equation is 2W plus X plus Y plus Z equal to 744. Third equation, W plus 2X plus Y plus Z equal to 672. And last equation, w plus x plus 2y plus z equal to 621. Each equation represents a different combination of ticket sales and their total amount. After obtaining the equations, we convert them into the matrix form Ax equals B. Matrix A contains the coefficient of the variables. Matrix X contains the unknown ticket prices W, X, Y, and Z, while matrix B contains the total amounts from each equation. The next step is to calculate the determinant of matrix A. Using cofactor expansion, we calculate the determinant and obtain determinant of A equals -1. Since the determinant is not equal to 0, matrix A is invertible. This means the system has a unique solution, so the ticket prices can be determined. After that, we need to find cofactor matrix of A. Since our matrix are 4x4, the manual calculation requires 16 cofactors in total. Instead of doing it manually, we let the cofactor matrix as shown.
In step 6, we find the adjoint matrix. The adjoint or adjugate of matrix A is simply the transpose of the cofactor matrix. This means we change the rows of the cofactor matrix into columns. After transposing C, we get the adjoint matrix shown on the right. This adjoint matrix will be used in the next step to calculate the inverse of matrix A. Now, in the step 7, we want to find the inverse matrix of A using the formula, where the inverse of matrix A is equal to 1 over the determinant of A multiplied by the adjoint matrix. From the previous step, we already found that the determinant of A is -1, and we also obtained the adjoint matrix. Next, we substitute these values into the formula. Since we divide by -1, every element in the adjoint matrix changes its sign. Positive value become negative and negative values become positive. After multiplying the adjoint matrix by -1, we obtain the final inverse matrix shown on the right. This completes the calculation of the inverse matrix of A. Now, we move to the final step, which is finding the values of each variable. We use the formula X equal to A inverse B, where A inverse is the inverse matrix that we calculated earlier and B is the constant matrix given in the question. Next, we multiply the inverse matrix by matrix B, and performing the matrix multiplication, we obtain the solution vector. The final values are W equal to 180, X equal to 108, Y equal to 57, and Z equal to 290. These are the values that satisfy the system of equation, which means we have successfully found the inverse matrix using the adjoint method.
The results show that different visitors categories are charged different ticket prices. The foreigner is the most expensive, which is RM290, which reflects a common pricing strategy used in tourist attraction where international visitors may be charged a higher rate. The adult ticket costs 180, while the child ticket costs RM108, making it more affordable for a family traveling with children. The senior citizen ticket has the lowest price at 57, providing a discount rate for older visitors. This example demonstrates how linear algebra can assist in financial planning and budgeting. By using determinant and the adjoint method, family can estimate the expenses accurately before visiting extreme work park. The project also showed that mathematical concepts learned in linear algebra can be applied to real-world situations involving pricing, budgeting, and decision-making.